the Tropical Archaeology Laboratory at the University of Calgary. My name is Siobhán Clarke, and I'm going to be your guide during our video tour of the lab today. I am one of the current PhD students working out of the lab under the supervision of PI Professor Julio Mercader. Before we head into the lab and begin the tour itself, I do want to start off by giving you all a brief introduction. This is the primary lab used by the Stone Tools Diet and Sociology project, which focuses on the reconstruction and contextualization of hominin ecologies through archaeological materials. This facility was completed in 2013 through renovations funded by the Canada Research Chairs Program, the Canada Foundation for Innovation, and the University of Calgary's Faculty of Arts. A unique aspect of this lab is that it is a clean room facility that was designed around preventing the contamination of archaeological materials during processing and analysis. Unlike other clean rooms you might be familiar with in archaeology departments that focus on preventing contamination of ancient DNA, the anti-contamination measures in place here work to prevent the infiltration of starch into the lab. To do this, the facility is equipped with a HEPA Class H14 air filtration system and other modifications such as the separation of the lab space into 3 distinct separate areas that work with the air filtration system to provide a positive airflow environment. The 3 zones of the lab include a gowning area and 2 separate workspaces. Now that the introduction's over, please join me inside the lab. Welcome back, everyone. We've now moved into the lab proper of the TAL. I've skipped the gowning area, but you can see my costume change here. I'll go over the specifics of why I did this in a little bit, but it basically comes back to this being a clean room facility and some of the anti-contamination measures that we have in place. As I mentioned outside, the research focus of the TAL and the SCS project is on reconstructing the lifeways of hominin populations, which includes things like the environment, diet, and certain aspects of their behavior. In order to do this, the lab is equipped for methodologies such as staple isotope analysis and analytical chemistry, ancient starch research, dendrocalculus analysis, petrography, phytolith analysis, and residue plotting of stone tools. The majority of our samples come from Olapai Gorge in Tanzania, but research collaborations have also brought in samples from the Coromos Archipelago, Equatorial Guinea, Kenya, Malawi, Mozambique, and the Atapuerca Archaeological Complex in Spain. As I mentioned earlier, some of the modifications to this lab include the separation of the space into 2 distinct areas. So the space that you can see behind me is referred to as the outer lab, and the primary function of this area is for sample preparation. So photography, data collection, so gathering weights, measurements, things like that before analysis, as well as the entry of that information into digital curation systems. The other main function of this space is for microscopy. We currently have 2 microscope stations set up. We have the stereo microscope, which is used for the residue plotting of stone tools. And we also have a light microscope set up that's currently being used for dendrocalculus analysis. Depending on the research demands at any given time, we can set up 1 to 2 more stations. So for example, we can bring in a microscope for petrography or another light microscope for either phytolith analysis or ancient starch research. As you can see, this is a fairly big open space. We are really lucky under normal circumstances. This means that several research students, projects, volunteers can all be kind of working in here at once. However, with some of the current restrictions, we are just limited to a single person in the lab at a time, so it feels a bit emptier than it normally does. Alright, so we've now moved into the second of those 2 distinct work areas I've mentioned a couple times now. This is referred to as the inner lab, and this is where all physiochemical analysis and bin sectioning for petrographic analysis occurs. As you can see, it's another fairly large space, so it's great for, again, multiple students and volunteers to be in here at once working on a variety of samples. So you can see the fume hood and chemical storage, several different centrifuges, the orbital shaker for agitating samples and chemicals, multiple ultrasonicators, Along the back bench, we have the saws and polishers for making petrography samples. There are also a couple ovens. One is the more standard lab oven, which is mainly used for gentle drying of samples. But then we also have the muffle furnace, or what we as students generally refer to as the pizza oven, despite no pizza ever actually being made in it. The furnace is used for high temperature drying, as well as the ashing of modern plant samples for the modern Vitalis reference collection. It is also used for the sterilization of ceramics and glassware used in all of our processing. On that note, the last piece of equipment in here is the autoclave, which is used for sterilizing plastics, metals, and some of the smaller glassware. So the study of ancient starch was the main reason for the development of this lab as a clean room. Starches are found in a wide variety of plants, and the variation in size, shape, and some of the different features of these granules can sometimes allow for identification to specific plant taxons, making them incredibly useful in interpreting vegetation in an area for environmental reconstructions, or even potential dietary or behavioral characteristics if these starches come from artifacts like stone tools. Today, starches are not only found in food, but are also an essential part of many consumer products and manufacturing processes. So for example, cosmetics, hair products, and laundry detergents all often contain starch. Similarly, laboratory products can often contain starch as well, not necessarily in the manufacturing, but just in the environment in the facility where they are being manufactured. Laboratory gloves are one example of a product that is often manufactured with starch. There's often a thin layer on the inside of the glove that helps with donning and removing the glove, but also is there to help protect the skin against irritation. So unfortunately, with the prevalence of starch in our modern lives, it makes authenticating archaeological starch a bit complicated, as I'm sure you can imagine. Is the starch that we're seeing under the microscope archaeological? Did it come from the artifact? Or did it transfer off of the excavator's t-shirt? Or was it even a bit more recent, transferring off of your hands from the sandwich you had at lunch? This lab and all of the protocols and materials used help mitigate these risks and verify that what we are seeing and interpreting is indeed archaeological in origin. So I've mentioned anti-contamination measures a couple times now. In the case of this lab, as you can see, I'm not in my street clothes anymore. I'm in clothes that are specific to this lab, and that includes a set of scrubs, a lab coat, face mask, hairnet, and gloves, as well as designated lab shoes and shoe covers. In the case of the clothing, they've all been washed several times in bleach to remove and destroy any errant starch granules. The other products, the gloves, hairnet, and everybody's favorite accessory today, the face mask, as well as all of the sample bags and tubes that are used in processing, these have all been manufactured with the guarantee of being starch and contaminant free. The SDS project also uses a mobile version of this clean room setup while in the field. So that includes specialized sample bags, tubes, the gowning area, designated lab clothing, air filtration system, sterilized equipment. Everything there, everything that we have in this lab here is repeated in the mobile clean room to ensure that the artifacts are contaminant-free immediately upon being excavated. Although the lab has been a bit quieter in recent months, just in terms of the number of students in here at a single time, there are still quite a few ongoing projects. So Professor McHeather is currently supervising both myself and a second PhD student. And his focus is on using residue plotting of Acheulean stone tools from Oldipie Gorge in order to interpret use function. For my own research, I am analyzing Denticalculus samples from Holocene populations of northeastern Spain. The laboratory manager is also currently processing a variety of samples from eastern Africa for phytolith analysis. Some of our recent master's student graduates have completed projects on topics such as the biodegradation of starch granules by soil microbial communities, the characterization and sourcing of lithic raw materials from areas surrounding Oldipie Gorge, and the creation of an isoscape of bioavailable strontium for the regions of Oldipie Gorge. Two recent doctoral graduates focused on landscape and environmental reconstructions of Oldipie Gorge's Acheulean, One used soil phytolymph analysis, while the second used gas chromatography mass spectrometry of lipid biomarkers from sediments. There's also some really exciting research on ancient starch coming up, as well as just ongoing research with the various collaborators that both the TAL and the SCS project have. And that wraps up our tour for today. I hope you've all enjoyed your brief visit to the Tropical Archaeology Laboratory. If you're looking for more information either on the SCS project or on the TAL, whether it's information on some of the specific equipment that you saw earlier in the video or more explanation into some of the ongoing projects, please check out the SCS website. Or if you are looking to work with Professor Mercader and the SCS project, either as a volunteer student or graduate student, or as a research collaborator, the contact information for you to reach out at is provided on there as well. On behalf of Professor Mercader and the SCS project, I thank you all again for joining me on the tour today, and I hope you all enjoy the rest of the Human Origins and